And today we are going to start with binomial logistic regression. So in the last week, we discussed regarding the linear regression, where we take one predictor variable and we try to see the relationship between the predictor variable and the dependent variable. The nature of the dependent variable should be continuous in this case. And then we have seen the multiple linear regression. Multiple linear regression when there are more than one predictor variable, and then we used to see the relationship between the predictor variable or the independent variable with the dependent variable. And in that case, we used to see like about what amount at beta and the intercept we learned. And we again have seen like what is a confounder, what is a effect modifier. We have seen how this interaction role when you have to see the interaction, how it changes the dependent variable. We touched a little bit, not very in detail, the interaction one, but yes, of course, we have seen like without interaction, confounder and the various assumptions of the linear regression. So yes, can someone summarize like few assumptions of the linear regression, because we have to now start from linear regression towards logistic. So the initial understanding of assumption, because the invent of this logistic regression, for to understand that you should know the assumptions of linear regression. Yes, so you can start writing in the chat box. What are the various assumptions of linear regression? Okay, I'll start saying like in case if we want to see the assumptions of linear regression, then the dependent variable should be continuous in nature, and the independent variable can be a mix of continuous and the categorical. That was the first. The second assumption is that whatever we say, like there should be linear association, means linear association between the dependent variable and the independent variable. And then we have also learned like there should be homoscedasticity. What is homoscedasticity? So basically homoscedasticity is we see that the variances across that line or line of best fit, that should be constant. That means there should not be a fanning out or fanning in, or we have learned like funneling out or funneling in. Those should not be there. And then we have also seen like there should not be a high influential point or high leverage point, or a Cook's distance should be less than 1. Because the Cook's distance, like what we call highly influential point, that is measured by the Cook's distance, and it changes the angle of the line of best fit. That is the regression line. So in linear regression, what we do, we see the association, and that association we try to, that is fitted into the line which is y is equal to a plus bx, where y is the dependent variable, a is the intercept, and b is the coefficient. Since we have all done that, that's why I'm just trying to summarize whatever we have learned in the previous sessions. And then one of the assumptions was like the data should not show autocorrelation, which we measure using the Durbin-Watson statistics. And the data should not, the independent variable, they should not be like they should not show multicollinearity. And again, we have like, how do we measure multicollinearity? So any data point, the independent variable where the VIF and the tolerance, these are the two statistical measures by which we can say that the independent variable are showing multicollinearity. So the value, if it is less than 10 in case of VIF, and in case of tolerance, if it is more than 0.1, then we say that there is no problem of multicollinearity. So these assumptions we always check before we go for linear regression, because then the value of beta, whatever value we are saying, that the value of beta will be accurate. Otherwise, it will give you the false value of beta. So now many of you were asking regarding the prediction, and like we often see the protocol and thesis where like in the clinical side and in the lab scenario also, that they want to predict something. But and the prediction is like they want to make a model. But we have shared a book with you people, that is the Klinbaum. And according to Klinbaum, if you say, he says that the prediction, like we know about a lot of study designs. So if you know go by the epidemiological methods, we have got like a case control study design, we have got the cross-sectional study design, and we have got the cohort study design or the longitudinal study designs. So if your primary aim is to make a prediction model, in that case, a cross-sectional study or a case control study is not the ideal way. That means you cannot make a prediction model if your type of study design is cross-sectional or case control. If your study design is longitudinal, that means follow-up study or cohort study, then only you can go for this prediction model. Why? Because in prediction, you are predicting something. So you are telling the risk or future risk of a disease. And in that case, you should know what is the exposure and what is the disease estimate. So you want to obtain a valid exposure disease estimate, and you want to obtain a good predictive model. That's the two main goal of these prediction equation. And in that case, you see that this is only possible because unless, if like you can recall your epidemiological methods, like if you know that the exposure has come first, then the disease happened. That is only possible if you start from a group of people who are healthy. They are not diseased. But in case of a cross-sectional and case control, when we go to the people or the study subjects, they are already diseased, whether it is a cross-sectional study or whether it is a case control study. So that case, we cannot obtain a model. It is not a good idea to go for a prediction if our study design is a case control study or a cross-section study. So that is only possible if your study is a follow-up study. So if our study is a follow-up study, then definitely the selection of variable, which this we discussed in the last session also last week. How do we select variables? Because remember, we were trying to figure out, like all of you were doing the interaction between the heart disease and gender and seeing whether it leads to any decrease or increase in the beta. Because we have said that if increase or the change in beta is more than 10%, then you will say that, it is a confounder. If not, then it is not. So how do you decide? So basically that is not the way. We were doing it just for our learning, but it should be based on theoretical background. So that variable selection, first step, if we talk about the modeling, so the first step is the variable specification. So what is variable specification? So there we choose based on the prior literature search, we specify which are the variables which will go into my model, into my predictive model. And there will be exposure and there will be disease. And along with that, there will be a lot of risk factor. And then there are two phenomena which we have learned. One is the interaction and the second was confounding. So it is said that according to Klinbaum, you should not do the confounding assessment before the interaction. So interaction assessment should be done first, followed by the confounding assessment. And if one variable can act both as a confounder and it can affect your interaction with one of your independent variable. So that's the theoretical background of how you will select. So selection of variable, specification of variable, putting what variable in the interaction, that is again driven by your literature search. It is not decided statistically. Even the confounder, although that's the rough guideline, that if your beta changes by more than 10%, then we say that it is a confounder. But again, confounder, whenever we are labeling an independent variable as a confounder, it should have a theoretical background. Means it should have some biological plausibility. And in the background, also in the prior literature, they should have shown something of this sort. Then only you can take those variable, and that you have to justify that. Like why you took a particular variable. It is not only the statistical like 0.2. How we discussed that in the univariable analysis, if any variable is showing a p-value of up till 0.2, we take that into model. That's the statistical decision. But before that, before testing that statistically, theoretically, what all variable you will test in the univariable, that is also decided based on the prior literature search. Am I making myself clear to all of you? That we don't decide any model making, we don't decide only on the basis of this statistical concept. This comes later. Of course, after the initial selection, you will subject your data to the statistical procedure or the statistical rigor, so that whatever you are predicting, that should have a sound scientific understanding, and that should be maybe acceptable to the academia. So that's why these nitty-gritties are important if your aim is to make a prediction or to predict something. But remember, case control and cross-sectional study design can never be used to make a predictive. We often say here also that PGs, especially from the clinical side, just on the basis of cross-sectional study, they want to predict something. But to predict something, because prediction is what? It's future. So for future, you should have a data which starts which is a longitudinal data. Otherwise, what is the problem? Like if you put those variables into the logistic or linear regression, it will give you an equation, because the software doesn't know what is the kind of data. He doesn't understand that whether that data is like cross-sectional or case control or cohort. But you as a researcher know regarding the nature of your study. So in that case, it will, whatever coefficient we have we know that this linear equation is y is equal to a plus bx. So what that a or the constant, that is it is never true. So whatever value it comes, it is not reliable. That's why your prediction equation. So your beta may be reliable, but not your constant. So if you are making prediction using a cross-sectional data or a case control, case control study, in that case, that model will be applicable only for that set of data, not for any other set of data. Only for that set of data, it will be applicable. Okay? Am I making sense to all of you? Okay. Priyanka has written yes. Thank you. So now, Sunil has also written yes. So we will start with this. We have shared one article with you, and that article is length of stay. So today we will see, this was the article. Okay, sorry. Surgical length of stay was the prior one. This was the book which I was referring. This is the Klinbaum, Statistics for Biology and Health. And this is the Logistic Regression. So they have very well written how you should take the variable, how it should be, what is the criteria of variable selection, variable specification. And they have in chapter 6 and 7. I'll just show. It is in the page number. If you go to 183. Yes, this chapter 6 and chapter 7. So this is the chapter, rationale for a modeling strategy. And they have given the guideline for best model, the 3 strategies, and the valid estimate of ED, like confounding and the effect modification. It was beyond the scope of this workshop to include all those concepts, because it's a little advanced, where they have taken many independent variable and they have tried to see the 1-way, 2-way, and 3-way. But those of you who are interested, you can go through this and you can just see. Coming to the article per se. So this was the article, Reason for Surgery Cancellation in a General Hospital, a 10-year study. So this study got published in the International Journal of Environment Research and Public Health. And the author are Sun Cho and Seol Lee. and they have done it on a data. So if you see the abstract, so this study research related to the causes that make the schedule. Yes, we have shared the book, Dr. Namrata. It is there in the reading material. The study research causes that make scheduled surgeries cancelled, not to be conducted based on research to derive issues in order to reduce surgery cancellation. So their aim was not to like predict something just to show the relationship. Why? Because that will help in taking the decision maker to, you know, make more specific strategies for those factors which lead to surgery cancellation. And they have analyzed the association of surgery cancellation with patient characteristics, surgical characteristics, and surgery schedule related characteristics using an electronic medical record data. So they have done using a EMR. A surgery conducted in the University Hospital in Korea over 10 years. Additionally, they examined the reason for surgery cancellation based on the patients and the hospital characteristics. Now, if you see the abstract, this is the article which we have used to generate the data. Again, the data is the created data. It's not the real data. It's just the data created for the workshop purpose. So if you see, their sample size was 6,333. These were the samples. And if you come down, so the study aimed to investigate the factors related to surgery cancellation and the reasons for the same. Additionally, the relationship of surgery cancellation and its reason with hospital and patient factors were also examined separately. So this was the objective of the study. Now coming to the this presentation. So again, let's say this is the prior example, the length of hospital stay. So if I just want to see the association of length of hospital stay with age. So in this case, we know we have done that, like we can make a formula of length of hospital stay and the age, and probably this is in the form of a linear equation where it is the y is equal to a plus bx. Okay, this you all know by this time that what is a linear equation. In a linear equation, you try to you try to give a formula which is a linear equation. All your data fits into this linear equation and which gives a predicted value of your dependent variable using the independent variable. So in this, we can predict the age of length of stay for 25-year patient, and this is a simple linear regression equation. Now, how come this logistic regression is different from this linear equation? So for linear regression equation, we know that there are a lot of assumptions. And the first assumption is your assumption of linearity, that the independent variable and the dependent variable should have a linear relationship. And the homoscedasticity, which we have learned, and residual should also have a normal relationship, normal distribution, and it should be like in the linear fashion. So residual, by this time we know what is a residual. So the difference between the predicted value and the actual value is the residual. So now if my aim, so it's not always like, if I want to know something, or if I want to know the relationship between yes and no variable, where the dependent variable is not in the form of a continuous in nature. Now let's see how we can complicate this situation further. So in this case, you have seen that how we have changed the data set in the previous one. So if you focus on this part, this one, what is the difference between this and this? Rest all three columns are same. The case number, the gender, and the duration of exercise. So what is the difference between this and this? So categorical, type of data, true. So in case of a diabetic foot, this is a categorical data because based on this, fasting blood sugar, initially we were taking, but here we are taking the diabetic foot. Similarly, if you see the marks obtained out of 100, this one and this, so what is the difference? The same. It is the categorical in nature. This one is categorical and this one is continuous. Okay, so that's the difference between the data set. So the outcome in this case, in that previous one, it is the categorical in nature. It is not continuous. So we have converted the continuous into the categorical. So how we can write the equation? So we can write like diabetic foot. So in this case, this one, like let's say here initially we used to write the blood sugar. Remember, this is the dependent variable. And this all we know like A plus BX1 and B1 X1, B2 X2. This is the equation. But in this case, if it is a categorical variable, instead of value, we will have to take yes and no. So we will make a equation with diabetic foot yes and no. And again, then what are the two values of yes and no? So if I take like 0 and 1, because in all statistical software, it is the number which is important for putting any modeling. Especially in case of a modeling, you need number. So there are only two numbers here, either 0 or 1. So can we have a linear equation like this in case if we have got a dependent variable only 1 and 0? Yes, all of you please write in the chat box. So Dr. Namrata is writing no. Dr. Priyanka is writing yes. So how we can have a linear equation if you have got only two values, 0 and 1? So linear equation is not possible because outcome here is binary where it has got only two values. So with this only two values, it is not possible to have a linear equation. So how this logistic we can overcome this problem? If our dependent variable is categorical, how we can overcome this problem? So the linear equation it's only possible when outcome has a continuous variable. So how to convert this yes and no to some continuous variable? How you can convert this yes and no, 0 and 1 to some continuous variable? Yes, all of you please write in the chat box. Any ways so that you can convert that into a continuous variable? Because with this I cannot, with 0 and 1 I cannot have this equation like this linear equation. So what we can do, we can calculate the probability. So all of you have heard the term probability. What is a probability? You must have learned that in your when you were doing maths. So probability, we always say like if you flip a coin, we say the probability of head is yes, it's the chance. Probability of head will be 1 by 2. So generally how we define the probability, it is the number of event by total number of possibility. You take the numerator, it is the number of event happening, and in denominator you take the total possible number of event that could have happened. That's the probability. And I think in epidemiology also you must have done that. What is the probability and the odds? What is the difference between probability and odds? So probability, we just what we calculate? We calculate the probability of outcome for each case. So how do we do that? In that case, we calculate the probability, the prediction probability. So the software calculates the probability of outcome of diabetic foot in a male of 32 years of age and who is doing a 50 minutes of exercise per day. Okay, that's how the software calculate probability. What is the probability of occurrence of a diabetic foot in male 32 years who exercise daily for 50 minutes? So for each row, and you know that each row is a study subject in case of a data and each variable is a column. So in this case, each variable which you are saying, each column, like gender, age, it is a variable, any data set. And each row, like row number 1, row number 2, row number 3, it is a case or a study subject. So this is if I want to know the probability, so the software calculates the probability of occurrence of a diabetic foot in a male who is 32-year-old and the duration of exercise is 50 minutes per day. Similarly, I can calculate the probability of occurrence of a diabetic foot in female who's 55-year-old and doing the 39 minutes of exercise every day. Similarly, likewise, the software calculates the probability of each and every case which are there in your taking all the variables into account. So how it calculates? It takes all the independent variable and it calculates the probability. So what will be your predicted probability? So your predicted probability of this diabetic foot, in this case, it's like 0.055. Similarly, the predicted probability of this female will be 0.643 and likewise. So this is how the predicted probability, the software calculates the predicted probability. But what is the problem? I mean, what is the characteristics of a probability? So all of you know that probability ranges from value 0 and 1. Do you agree? It will have a range of values. Like in the previous case, what was happening? There was only two values, 0 and 1. But in this case, you will have a range of, if you convert the yes and no response to probability, you will have a range of values from 0 to 1. Okay, the way you have seen here. So here you have got a range of value. If I would not have converted this present and absent into this, I would have only 0 and 1. But since I have converted this, I have not, means the software does it. Okay, this predicted probability is calculated by software. You don't need to know how it is calculated. You should only know there's a method which we'll see later, what method the software uses to calculate this probability. So but the probability has this restriction that the range of value, there is a lower value which is 0 and the higher value is 1. It cannot go beyond 1 and it cannot be less than 0. Now, if let's understand how on the basis of that prediction your occurrence or the chance of happening is decided. So if your probability, and like Dr. Sunil has just written, probability means chance. So if the value of probability is 0, so what will be your prediction? So you will say that no chance of outcome occurrence. And if the value of probability is 1, what you will write? That there is a definite chance of outcome occurrence. Do you agree or not? Yes? All of you, please write in the chat box. Okay. So yes, you agree. Now, if the predicted probability is 0.12, what will you say? That that particular outcome will occur or won't occur? Yes? If the predicted probability is 0.12, what will you say? It will occur or it won't occur? So 12% chance of occurrence. But again, whether it is near to 0 or near to 1? Less. So Dr. Sunil is writing chances will be less. If it is 0.93, then what is your answer? If probability is 0.93, it is near to 1 or near to 0? Just understand like this. If a probability is 0.93, okay, so more chance of occurrence. But if it is 0.55, then you are midway. Means it is definitely it is nearer to 1. So in case if the value of probability is 0.12, we will say that nearly there is a no chance of outcome occurrence. If the value is 0.93, we will say that nearly there is a definite chance of outcome occurrence. But if there is a 5 value, predicted probability is 0.55, yes, it is a kind of intermediate and it is difficult to decide. So in that case, the software fix this rule. So software resolve this dilemma that we fix the value, and what is that rule around it? So whenever the value of probability is less than 0.5, we will say that the outcome not occurred, and whenever the value of probability is 0.5 or more than 0.5, we will say that the outcome had occurred. Now you are ideally you can set this probability cutoff rule based on your study. But by default, you say all software that takes the probability of occurrence of an event to 0.5. So if the value is 0.5 or more than 0.5, then a particular event, you will say that a particular event has happened. And if it is less than 0.5, then you will say that it has not happened. So now again, this was just we were discussing how the softwares will say that a particular event will happen or not happen. So in that case, if you see this, so in this case, you can see diabetic foot present, what is the probability? 0.055. And now, if it is the probability is 0.643, ideally, according to rule, what should have been the situation? According to rule, if my probability is 0.643, will I have the diabetic foot or I will not have diabetic foot? Yes. So I will have diabetic foot. Similarly, but the actual situation is showing that it is not having. Okay, because it is absent. So this is the mismatch, and that's the residual. So residual here, generally, it is not calculated the way we have seen in the linear regression. Similarly, if you this is the mismatch. Mismatch means the model is saying that the diabetic foot will be there. But if the predicted probability is 0.163, what will be your answer? What will be your answer? Yes, no. So now coming to the previous discussion. So this was regarding the rule. So any probability, predicted probability, if it is more than 0.5, then we'll say that there's no occurrence of there's the occurrence of the outcome. And if it is less than 0.5, we'll say that there's a no occurrence, means outcome has not occurred. So now that was regarding the predicted probability. But how this predicted probability will help us in the formation of a linear regression equation? So initially we started with diabetic foot yes and no. Remember that continuous variable, we have categorized that into a categorical one. And instead of using yes and no for outcome variable, now I can write here, instead of this, I can write the predicted probability of a diabetic foot. And then I can write 0 and 1. So do you agree up till this point? So instead, because why we have converted this yes and no? We have converted this yes and no to a probability. And we have decided one rule. And now that probability we will take as a dependent variable. But there is a problem with this probability also. Because the probability can only have to it can lie between 0 to 1. Probability value cannot go beyond 1, and probability value cannot go less than 0. Less than 0 means fraction. But we know that it is a linear equation, and in linear regression we have learned regarding all the equation that should be fitted, like y is equal to a plus bx. So for linear assumption to make the outcome should have a freedom of range. So freedom of range, it should go more than 1 also, and it should go less than 1 also. Less than 0. It is not less than 1, it is less than 0. Let me change this. It is less than 0. So the outcome variable, that we call it as a floor and ceiling effect. Floor, as what do you mean by? You will see in textbook, they write it like there is a floor and ceiling effect if you convert your yes and no to predicted probability. What is a floor and ceiling effect? Ceiling effect is it cannot go beyond 1, and floor effect is it cannot go less than 0. So how this problem we tackle? So this problem is tackled if you convert this probability into odds, then this problem, like you can solve this problem. So how there's a formula of converting the probability to odds. And odds is like in numerator we take probability of happening, And in denominator, we take probability of not happening. And how we calculate the not happening? So 1 minus p is not happening because total value of probability is 1. So probability of happening something, then probability of not happening something will be 1 by p. And that's how we know the formula of odds is p by 1 minus p. So using this formula, we can convert our probability into odds so that we will not have a ceiling effect. So the value can go beyond 1 and value can go less than 0. It will have a value less than 0 also. Means that value of this thing. So we have converted. So this odds, no. So this conversion of odds help in tackling your ceiling effect. Means now the value can have more than 1. Because if you convert the all of you please do this exercise. You convert the if the probability of occurrence of a diabetic foot for a person is 0.75, but again I have written the answer, then what will be the odds of occurrence? So you can see like 0.75 and in the denominator 1 minus 0.75. So it will be 3. Okay, so Bhavna is asking repeat the ceiling and odds. So ceiling is like, here I was talking about this, Bhavna. You know that what is a probability? Probability value will always be between 0 to 1. Do you agree? Okay. If you agree, then it has got a ceiling effect. 1 by, because it cannot go beyond 1. Ceiling means it is now restricted by a ceiling. It cannot go beyond 1. So 1 is acting like a ceiling for the values of the dependent variable. So if you convert that probability into odds, you know that for the same predicted probability, the odds can go more than 1. In this case, you can see it is 0.75. So the odds will be 3. Let's say you calculate the odds if the predicted probability is 0.9. All of you please calculate odds for a predicted probability of 0.9. You can do it verbally also. In the numerator, it will be 0.9. In denominator, it will be 1 minus 0.9, which will be 0.1. So it will be 9, isn't it? So yes, Namrata, you are right. So any predicted probability can be converted into odds. And now that ceiling effect of 1 means like it cannot go, if you take probability, it cannot go beyond 1. But if you take odds, the same value for the same value, the odds, if you take odds, it can go beyond 1. So actually through this example, what we are trying to achieve, why we are doing so much of changes in the dependent variable. Yes, please write in the chat box why we are doing so much of drama, converting the 0 to 1 to probability, converting probability to odds. Why we are doing so much? To meet the assumption of linearity. Yes, means 0. If the response is 0, 1, you cannot make that linear assumption met. So to meet that linear assumption, and we have not discussed, but again, the other assumptions like homoscedasticity also, you have to make that value as in the form of a linear equation. So that's why you have converted now the probability to odds. Now, what is the problem with odds? So this is the predicted probability, and if you calculate the predicted odds, so these will be the predicted odds. So odds you can see now. Now it has got a value of 25 also. If the predicted probability is 0.96, the odds is 25. And if the predicted probability is 0.1, the odds is 0.2. So this odds, what it does, it removes the ceiling effect. Ceiling means the upper value can go. But again, if you say like from less than 0 means like negative, then we'll have to see. For that, what it does, there's a link function which is known as the logit. So what logit does, if you take the natural log of this predicted odds, which is called the logit, then it will serve two purposes. It will remove the floor effect also, and it will have a symmetrical effect also, because there's a problem with the odds also. What is the problem with the odds? If I take the odds here as a dependent variable, odds of diabetic foot, then I will form a linear equation like A plus B1 plus B2 plus B3. Similarly, but odds have a problem that it is not symmetric around the zero. What do I mean by symmetric around the zero? That means how do we calculate odds? We have got reference level. So now let's first take this example. If I say that the odds of a diabetic foot among male is 2 times higher than female, then we can say that the odds of diabetic foot among female is 0.5 times lower than male. If you focus on this example, yes, how do we convert? If you change the reference level, we do not, like if I say odds is 2 times higher than female, if I change the reference level, how will I write? 1 by that particular odds. So you have to write like 1 by 2. So I can say that the odds of diabetic foot among female is 0.5 times lower than male. Can I say like that? So what I did here, if I have changed the reference here to male, so what I'll do 1 by 2. So 1 by 2 means it will be 0.5. Similarly, if I am saying that the odds of diabetic foot among male is 3 times higher than female, can we say that the odds of diabetic foot among female is 0.33 times lower than male? Can I say that? How I have done? If I change the reference level, I will do like 1 by 3. So 1 by 3 is equal to 0.33. So that's the rule. If you want to change the reference level, you have to put that in the denominator. Similarly, if I say that the odds of diabetic foot in male is 4 times higher than female, what will be the odds of a diabetic foot if I change the reference level? So it will be 1 by 4. So it will be 0.25 times lower than males. Do you all agree with this? Okay, so if yes, but again, you will see that this is not symmetrical, because what is symmetry? Symmetry is like if I say that the fasting blood sugar of male is plus 20 milligram higher than female, then in that case, we can say that the blood sugar of female is 0.20 milligram percent lower in female with respect to male. If I talk about difference, then I can talk like this, plus and minus. So again, this similar example, if I say that the fasting blood sugar of male is minus 8 milligram percent lower than in male with respect to female, can we say that the blood sugar in female is plus 8 milligram percent higher in female with respect to male? Can I say like that? So here you will find symmetry, but here you will not find symmetry, because it is saying 2 times and then 0.5 times, 3 times and 0.33 times, 4 times and 0.25 times. Proportion. So it's a proportion. That's why you cannot say like that. So how we can tackle this problem? So, but in this case, talking about the same thing, if I am taking this odds, then I'll have to form two equations. So I will form like odds of a diabetic foot. In case if I am taking female as a reference, I will put this coefficient as 4. And if I am taking male as a reference, I will have this 0.25 as a coefficient. If I change the reference level, if I have to put that, because I have to fit that into a regression equation where this beta is the coefficient. Okay. So if I have to do like that, it is not symmetrical. So I'll have to have two equations then. So that's why to solve this problem of asymmetry, if you convert this odds into natural log, then you will have symmetry. So all of you, please do the natural log calculation. You do the natural log calculation of 4 and 0.25. Yes, I will use, there's a natural log calculator. This is the natural log calculator. And I will put like 4. If I put the value of 4, then it gives the value of 1.38. And if I put the value of 0.25, it gives the value of minus 1.38. So sign has changed. And by this, you remove the floor effect also. Means it can go now to negative values also. Less than 1. Less than 0. Sorry, not 1. Am I making myself clear to all of you? How this natural conversion of natural log to that particular log odds ratio removes the problem of symmetry, asymmetry, and removes the problem of floor effect. Ceiling got removed by odds ratio, which when we, not odds ratio, when we converted that to odds. An effect of floor that got removed if we convert that odds into a natural odds, and that if you take the natural odd, that is known as the logit function, and that's why the name is logistic regression. This logit, because of this logit function, we call this regression as logistic regression. So if you take the, I'll once again show, if you take the 4 as odds ratio, it will give you plus 1.38. This is plus 1.38. And the same if you take like 0.25, which was there in the female, then it will give you minus 1.38. So that shows that it is symmetrical. So this will solve the problem of asymmetry, and this function is known as the logit function. So the same value which we have calculated in the natural log, so now it is called as a logit function, and now you can have an equation like a plus 1.38 into gender, and a plus, here only the sign will change into gender, because then you can have a symmetry around this. Okay, so that's why we convert that into a logit function. So finally, with the help of logit transformation, we finally got a linear equation for a categorical outcome prediction. So here in the dependent variable, it is the logit. This is the logit of your y. Whatever dependent variable you take, this is the logit of your y, and this is your logit of your independent variable. This the logit of b, means this is the beta coefficient. So this is also logit, and that's I will show you how it gets converted. You don't have to do it, but this gets converted. And this, if you, this is for the simple, if you have one variable. If you have got many variable, then here also it is logit, and everywhere this is logit. So this is the natural log of the odds. Okay, that's the logic. So that's the link function. That's how we describe the logistic regression equation. So if I have to explain the symmetry again, first, have you understood the asymmetry?
No, ma'am, that part I missed. Please repeat.
Which the asymmetry you missed?
Yes, ma'am. Asymmetry and symmetry. That one.
So have you, this is asymmetry is...
This, up to this, ma'am, I have understood. After that, I missed her.
So this is asymmetry. Why? Because if you say that male is 2 times higher than females, then you cannot say that the females are 2 times lower than males. That you cannot say. In that case, you will have to say 0.5 times. Okay. Similarly, if you say that a diabetic foot among male is 3 times higher than female, if you change the reference category, this value gets 0.33. You cannot say that this is thrice lower. Oh, okay. So that's why it is asymmetrical. So to make that symmetrical, we have taken the log odds. We have converted that odds into a natural log. And if you convert that odds into so there are two here. If you see, there are two. This is 4. If you take this as a coefficient, and this is 0.25. So if you take a natural log of this, that's why I said that if you go to this natural log calculator, and if you put like 4 here as a natural log, this I'm using a Google calculator, and if you press 4, what is the value of this natural log? This is 4, 1.38, and the other odds was 0.25. So instead of 4, if you write 0.25, then it will be minus 0.38. So only with the change in sign, now it has got a symmetry. The value is same with a change in sign. That we mean by symmetry. And
Yes, ma'am. Thank you.
that's how with this logic function, this logic function serves two purpose. It makes the value symmetrical around 0, and also it removes the ceiling effect. Why? Because now the value can go in negative. That's why the value was minus 1.38. Okay. So the value can go negative. So that's why we take, so this all exercise we have tried to explain how the assumption of linear equation, that is the linearity, because if you want to go for this logistic regression, that assumption should be met, and that can be done using this logit function, and how we have reached up till this logit function, that we have tried to explain. So now if I have to summarize how we have done it, so linear equation is not possible with dichotomous values like 0 and 1. That's why we have converted that 0 and 1 into a predicted probability. How we have decided the rule for predicted probability? If the value of predicted probability will be more than 0.5 or 0.5, we will say that the occurrence have happened. And if the value of predicted probability is less than 0.5, we'll say that it has not happened. But again, the probability has got a limitation. The floor and the ceiling effect. What is the ceiling effect? The probability value cannot go beyond 1, and the probability value cannot go less than 0, that is negative. But to satisfy the assumption of linearity, we should have got a wide range of value, which should go from minus infinity to plus infinity. And that's why we convert that into this probability into a odds. So if we convert this probability into odds, then the problem of ceiling gets solved. Why? Because if you convert the probability into odds using a formula P by 1 minus P, then the value of that odds can go more than 0. But again, the problem of floor and the asymmetry remains. So if you take the natural log of this odds, then the problem of that floor and ceiling gets solved, because now there is a symmetry around 0 and the value can go less than 0. That is in negative. And now we have got a linear equation. So if we convert that into a logit, the dependent, this one, if we convert that equation into a logit of y is equal to a plus logit of b into x, then it satisfies the assumption of linearity. Did you get it up till this point? Why there was a need of, and what is this logit function? Actually, you don't have to do it. The software does it. But you should understand the difference between a linear and logistic regression. Why? Because in the output also you need to, the interpretation is little different. Because interpretation here, it will give you the value in the form of a odds ratio. There in the linear regression, how we have understood the coefficient, there the coefficient was the difference between the, if it is a categorical variable, we used to say that this that much coefficient will be the difference of the values between the two levels. In case of a logistic regression, the output there is in the form of a odds ratio, and you need to interpret that odds ratio. And how we have reached to that odds ratio, that we have just explained just now, that you took a logit of that and that gives you the logit of a particular coefficient, that gives you the odds ratio. So now, if you see, these are the values of probability, 0.01 till 0.99. These are the odds. Now, if I took the log odds, this is the log odds or the logit, you can see it is symmetrical around 0. So 0, then minus 0.41 and plus 0.41. Again, if you go here, minus 0.85 and again it is plus 0.85. So with the same, like if you see like probability increasing 0.1, 0.2, 0.3, 0.4, 0.5 like this, and it is symmetrical around 0. Here all the negatives. So you can see if the odds is less than 1. Here all odds are less than 1. So the value of this logit will be negative. If the if the odds is more than 1, then the value of this logit will be positive. So you will find in your coefficient many times this is negative. Negative logit means the odds ratio will be less than 1. Please remember this. This is important. We will see that when we will do the data analysis also. But negative logit means that your odds ratio will be less than 1. Positive logit means that your odds ratio will be more than 1. Now regarding the means predictor variable and the sample size assumption. Like how, before that I was talking about like that 0 and 1, yes and no, it calculates the probability. So how that probability is calculated? So basically that probability is calculated using a technique which is known as the maximum likelihood technique. So what is this maximum likelihood technique? Basically what software does, taking all independent variable into account, it calculates the probability of that particular dependent variable, and it does it in many iterations. It runs that in many times, and then it selects that particular probability which is like maximum, means with the least distance of the actual one. So that's why the software makes that equation in the background, like this logit of this y, which is the dependent variable. It makes these equations, and this beta 1, b1, b2, b3, b4 are estimates associated with each predictor variable, and it runs that many times, and then finally it selects the one, the most nearest to the actual one, the predicted probability, and that is known as the maximum likelihood estimation technique. So how this predicted probability is calculated? The predicted probability is calculated using the maximum likelihood technique. The software does it. It runs this equation in the background several times to find a suitable predicted probability, and it selects the one which is showing the maximum value of the predicted probability. So to get the best value of estimate for each predicted probability, it selects the particular probability that is having a maximum possible value, and that software does it in the background by hit and try, which we call it as an iteration. So that's what I was talking, that in many, like it runs those values many times, and then it shows you, or it gives you the a particular value of a probability, which is known as the maximum likelihood estimation. So is it okay up till this point how we have reached from linear regression to logistic regression? So linear regression, we have categorized the linear outcome into the two, and this probably we are talking about the binary logistic regression because it has got only 1 and 0 value. There are other types of logistic also, but the basic will be same there also. So we have converted the linear dependent variable into the categorical one, but it was having only 0 and 1 value. So we have now the software does, how the software does it? Software calculates the probability based on the maximum likelihood estimation, and using that MLE, it calculates the probability, and the probability value, again, it has got a ceiling and floor effect. So to remove the ceiling effect, the software calculates the odds, and to remove the floor effect, it takes the natural log which of that odds particularly, and then our all problems are solved now, and that's why now we can run the logistic regression equation. So again, the same thing, how the response variable, there are two types of variables here also. There's outcome variable, response variable, or the dependent variable, or there is an independent variable, predictor variable, or the explanatory variable. So these are the names of the traditional names which we follow in case of a logistic regression, the way we have done for the linear regression. No difference from that. So with the help of possible predicted outcome, now here you will see that all these outcome or the dependent variable are categorical in nature. Like whether an admitted newborn will get sepsis. If I am coming to this first one, so sepsis, yes and no. A categorical one, whether a family will fully immunize the child. Again, a categorical one, whether a mother will exclusively breastfeed her baby. Again, a categorical one, yes and no. Whether a pregnant woman will have preeclampsia, yes and no. Whether a patient will comply to treatment. Adherence, yes and no. Whether a students will pass, yes and no. Whether a village will adopt a government policy, yes and no. Whether a person will commit suicide, yes and no. And whether a person will need a ICU admission, again yes and no. So in all these variables you have seen that it is the dependent variable, the answer is in the form of a yes and no. But now there's a problem because you take many variables whenever you try to see the association, or whenever you are doing a research. Now what variable to take? For example, if for a particular outcome there are many variables here. There's a serum sodium, gender, urine output, blood group, number of antibiotics, sugar level, attendance, diabetes, systolic blood pressure, residence. So what predictor variable to take? How will you decide that? Yes, please type in the chat box. So Dr. Sunil is writing previous literature. Yes. So first is the selection of variable, which we have just discussed, that the selection of variable should be on the basis of previous literature, the variable specification. And then you will see the statistical. So the first step will be the literature review. And yes, like Priyanka is saying, p value less than 5, 0.5 or 0.2, Priyanka. Yes, that is the second step. Whether you will include that in your model, that is your study, that can be your statistical this thing, but to put that into a particular equation or to take that into a model formation, that decision will be decided by the prior literature. So first, on the basis of, let's say, on the basis of the literature, we need to choose few probable predictor variable, which we think it can predict the outcome of interest. So suppose we have selected 10 probable predictor variable based upon the literature review on the clinical experience. And now so first on the basis of clinical experience and literature review, I will have an initial list of my predictor variable. And now I'll do a statistical analysis, what Priyanka was saying, and then I'll fix a value of, let's say, generally we are little lenient in selecting the variables. So we generally keep a p value of 0.2, and in the univariable analysis, like first we do one by one, and we see the p value in the univariable analysis, and then in the univariable, if it is up till 0.2, we take those variables for our final model making, or making a logistic regression equation. So for this, again, we need to run one-to-one analysis to find the association between a predictor variable and an outcome variable. and this is called as a bivariate analysis. So variable 1 an outcome, variable 2 an outcome, variable 3 an outcome. That's how we'll do it one by one. And the way we have discussed that we are a little lenient in selecting the most significant variable, and we select the variable where the p-value is up till 0.2. Generally, we are not that strict that we will select up till 0.5 per 105. So we select a variable where the p-value is up till 0.2. And then the predictor variable, we know that here the dependent variable is categorical in nature, but the independent variable can be a continuous or a categorical one. So now you may ask this question that why we are not selecting the variable which are very much strictly like 0.05, why we are lenient in selecting the significant predictor variable. So why? Because we have seen that generally variables which are like up till 0.2, many times with many other variables, their p-value, it becomes significant. So there are chances that 0.2 can come down to 0.05 in case of a multivariable analysis. So that's why we choose the variable which are having a p-value up till 0.2. So now we have selected the variables. Now what to do next? So we will use the final selected predictor variable for our logistic regression equation. And this basically here we know that this all talk is about the binomial logistic regression. So this is about predicting binary variable when the target variable is categorical or continuous. So now what is the character? So there are various types of logistic regression, but here we are discussing the binomial logistic in this session. So what are the characteristics? So why binomial? Because it has got a dependent variable has got two levels, 0 and 1. So all that previous example you have seen that yes and no, yes and no, yes and no. So since there are two levels of a dependent variable, that's why its name is the binomial logistic regression. So this why there is it generally it is used in prediction because it predicts a probability for a dependent variable, and the dependent variable here is a dichotomous, or it has got two levels, and independent variable can be both continuous and categorical, and it can have two levels or more than two levels. So now if you see the comparison between linear and logistic regression. So in case of a linear regression, there the dependent variable is continuous, the way we have seen in the previous week. If there's a blood sugar is the dependent variable, then we cannot go for a logistic. So for linear, you should be the dependent variable should be continuous in nature. If the dependent variable is categorical in nature, in that case, we will have to go for the logistic regression. Independent variable can be both categorical in this thing. So this is logistic. If I have to choose the logistic regression, I'll choose the option 2. Similarly, if my research question is, if I want to predict the at the time of admission, which patient of COVID may need ICU. So will I go for linear regression or logistic regression? Yes, all of you please type in the chat box. If my research question is, I want to predict at the time of admission which patient of COVID may need ICU, then yes, logistic. Why? Because this is a dependent variable, is a categorical in nature, and to be more precise, it will be binary logistic, but I have not put that name, that's why. Now, I said that in logistic, the outcome will be in the form of a odds ratio. So there are two types of odds ratio. One is the unadjusted odds ratio. So what is unadjusted odds ratio? When there is only one independent or predictor variable, we call it as unadjusted odds ratio. When there are more than one predictor variable or the independent variable, we call it as an adjusted odds ratio. And this one independent variable, we call it as a univariable analysis. And more than one, we call it as a multivariable logistic regression. So what are the assumptions? So assumption, we know that all the assumptions which you have learned in the linear regression. That holds true for logistic regression also, because using that logit function, now we have converted that dependent variable into a continuous variable using that logit of y. So that's why the underlying assumption is same as you have learnt in the linear regression. Like there also, here also the dependent way, there are few differences, very subtle differences. Like here the dependent variable that is dichotomous, that is nominal variable with two outcome. The independent variable that is measured either on a continuous scale or on a nominal scale. And there should be independence of observation. So independence of observation, we all know, and generally we talk this regarding the residual. So the residual should be independent of each other, and that is measured using the phenomena is known as the autocorrelation, which is measured using Durbin-Watson statistics. Probably in this interface it doesn't give you the Durbin-Watson statistics, but in linear regression we know that there should be independence of observation, and independence of observation is again a study design issue. We have discussed this, that if you have considered one individual once in your data set, you should not consider that individual again. And for this, I think classically I always give example of like Supriya's thesis, which is the PG here in the Department of Community and Family Medicine. So she started with the prevalence of the antenatal depression in the pregnant women. And initially she did not, probably we forgot, and by mistake, I think she interviewed one woman twice. Or even if she had not done, there was a possibility that she will interview one woman twice, because for antenatal checkup, one woman comes many times to a health center. And if you don't ask this question, like, have you answered this questionnaire before, then there are chances that the same, you will end up taking same women twice, or in exceptional cases, thrice also, if she doesn't tell you. So that violates the assumption of independence of observation. Why? Because you have taken one woman twice or thrice in your sample collection. That means each row, that we call each row, is a individual. So there are two rows in your data set which are exactly same. That we mean by the independence of observation. Same means it is of the same person. There might be few changes, but it is of the same person. So there should be independence of observation. And regarding the sample size here, generally we say that minimum of 15 cases should be there per independent variable. And this 15 is 15 outcome variable. Outcome variable means in that binary logistic, there is something known as yes and something known as no. So occurrence of that particular outcome where that all yes is there, that should be minimum 15 per variable. And then the next one should be the procedure to test for linearity. So here the assumption of linearity is tested using the model fit and pseudo R-square statistics. That we'll see in once we run the statistics. So if the pseudo R-square statistics is between 0.2 to 0.4, we say that it is linear. And I think model fit statistic, it should be more than 0.5. So now assumption, there are other assumptions also, the way we have seen in the linear regression equation, like the two or more independent variable, if they are highly correlated with each other, they creates confusion that which independent variable is contributing to the variance explained in the dependent variable, which is detected by either inspecting the correlation coefficient, which should be less than 0.8, or there are other statistical measure like variation inflation factor, which is the VIF. The value should be less than 10, preferably should be less than 5, and the tolerance, which is opposite to VIF. I think multicollinearity we have discussed. So, and category prediction also we know that if the predicted probability is more than 0.5, then 0.5 or more than 0.5, we will say that a particular outcome have happened. And if the predicted probability is less than 0.5, then it classifies at the event not happened. So the most important in this logistic regression is the linear function of this logit, which we call it as a linearity in the logit. And that is only done with the log odds transformation of the dependent variable. And how this linearity assumption states that it says that every 1 unit increase in the continuous independent variable, the value in the logit of the dependent variable increases by a constant amount. And I was discussing about the model fit statistics. So there are two model fit statistics. There is a goodness of fit statistics and there's a badness of fit statistics. So goodness of fit statistics says it's done by the R square and the pseudo R square. We call it as a pseudo R square. Why? Because it is based on the calculation of probability. So the way we have done in the linear regression, how we have done in the linear regression, it says you like that much percentage of variance in the dependent variable is explained by the independent variable. But here you always compare this pseudo R square because this pseudo R square is based on probability, which you always say that how much is the improvement over the null model. And that's how you interpret this pseudo R square. These are not the true R square because it is based on the probability. And then there is something known as the badness of it. So this badness of it, you want like these values should be this AIC and BIC value. It should be the change in. If you see the change in AIC, there is no absolute value of this AIC and BIC. If there is a reduction in the AIC and BIC value, you say that the previous model was a better model. And this we will see as an exponent calculator, because how you can convert that logit back into the odds ratio. So if you take the exponent of that logit, it converts back that logit to odds ratio. Because you cannot interpret this logit. How will you say that 1 unit increase in logit is causing increase in the dependent variable by a constant amount? So there's a difficulty in interpreting it or saying it. So that's why the software, what it does, it takes the exponent of that particular logit and which is known as the odds ratio. So which we will calculate using this exponent calculator. We'll see how to calculate it. Now let's run the analysis in JAMOVI. So are you people clear theoretically up till this point? Or otherwise we will go to the problem, like what are the data and the putting that commands and then learning the interpretation. So should we have a break of 5 minutes? Then we'll again be back, or 10 minutes break? So we all are back and we are going to see the data set. So if you see, so you all are familiar with the JAMOVI interface. So I'm not going to tell you the interface of JAMOVI because by this time we know that you all know all the functions of JAMOVI well. So if you see the variable, I'll just explain the variable and the question. So this is the question. And the same article which I have just shown you, the surgery cancellation, this article we have used. This one. Regarding the book, Dr. Namrata, we will, I think, yes, you were right. It is not there in the folder. So we'll put that in the shared group. I mean, in the group, we'll share that book. So this was the article, a reason for surgery cancellation. So let's see which are the variables. So if you see, we'll start with gender. So if you see gender, it has got two levels. It is nominal variable, female and male. So it is important to remember the reference level 1 and 2. So 1 is female and 2 is male. If you go ahead, age is a continuous variable. Then comes your age group. So we have categorized the age group also. And if you see using the transform option, so if you press on edit, you can see like what is how we have transformed it. So if the source is less than 20, it is less than 20. then 20 to 60 and more than 60. So these are the three age group category. And then you have got this weight. Weight is again a continuous variable. Height is a continuous. And then the BMI, using this compute option, we have calculated the BMI. Then this chronic disease has got levels like either there is a none, diabetes 1, hypertension 2, and both is 3. So there are 4 levels of this chronic diseases. Admission type, if admission is through OPD, it is 1. If it is through IPD, it is 2. The department, there are various departments like ENT, general surgery, OBGY, and orthopedic. So basically 4 departments. And this is anesthesia type. So 1 is for general anesthesia and 2 is for regional anesthesia. Season, like 1 is for summer and 2 is for winter. And days of the week, like there are 7 days, like Monday, Tuesday. So 1 is for Monday, and similarly 2, 3, 4, 5 is still Friday. It is the five levels in the days of week. And then if you see the surgery type, whether it is an emergency surgery or a planned surgery. So an emergency surgery is labeled as 1 and planned surgeries as 2. Then surgery status, this is my outcome variable, whether the surgery was done or whether the surgery got cancelled. So remember, if you, like my research question here, if you see this, my research question is reasons for surgery cancellation. I'm not studying the reasons for surgery happening. So that's why generally here, one value you put to such variable where it is like which is my main outcome. So I am studying the reasons for surgery cancelled. That's why surgery cancelled, I have given this number 1 and 0 as done. If your interest variable is surgery done, in that case, ideally what you should do, you can change the reference levels also, but then you should label this as 1. But again, by default, what it does, JAMOVI, it takes the lower value as a reference value. So that's why cancelled I have given 1, and it takes the reference value of 0, which is the done in this case. And then I think that's it. So this is my dependent variable, surgery status, which is 0 and 1, which is having how many levels? Yes, all of you please write in the chat box. My dependent variable is having how many levels? 2. Yes, because we will see if the dependent variable has got more than 2, then the choice of logistic will be either ordinal or multinomial. That's why it is important to see how many levels of dependent variable are there in case of this regression. So logistic regression, again, this logit function, like there are other types also. This is binary logistic. Then there is a multinomial logistic, and then there is a ordinal logistic. So ordinal logistics and multinomial. There, instead of 2, we have got more than 2 levels. So here, if your dependent variable has got 2 levels, yes and no, then you can go for a binary logistic. Now coming to the data, and this comes as a general package. This is in the option of regression. So you go to this analyze regression. We have seen correlation matrix. We have seen this linear regression. Now in logistic regression, you will see there are 3 options, the way we were just discussing. If it is 2 outcome, then it is binomial. JAMOVI also guides you. If there's an n outcome, this is multinomial. And if outcome is ordinal, that means it is having an ordered nature, then it is the ordinal regression. So what option I will click? I will click binomial. So if you click binomial, this will appear. Now coming to the dependent variable, So how you will go? So first I said that you have to select the variables to be put into this. So let's say like these are the variables which I have selected based on the literature review. What are those variables? The variables are age and gender. So these are the variables. So the way how we have learned, you will select the variables based on literature review and the clinical experience. So the gender, age, BMI, and then all these categorical variables like presence or absence of chronic disease, admission type. Admission type was OPD versus IPD. Department, there were 4 departments: medicine, surgery, gynae, and ortho. Anesthesia type, regional and general. Summer and winter 2 season. Days of the week, 5 days of week. And surgery type, it is the cancelled or the surgery done. So these variables I have selected based on literature review. Now, which variable I will enter in the final table, that is decided based on the uni variable. So how I will do the uni variable? Yes, planned and emergent. Surgery type. Okay, yes, sorry. This is the surgery status. You are right, Dr. Hilda. I'm sorry. Surgery type is planned versus emergency. So which now how I will decide, like out of these many, how many variables are there? Let me 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10. So there are total 10 variables here. So which all variable to take in the final model? How will I decide that? Yes, all of you please type in the chat box. How should I start my analysis? One by one. Probability. Okay. So Dr. Hilda, generally, remember, yes, Dr. Namrata, we have studied like we will do a univariable, which is also known as the unadjusted odds. So unadjusted odds are based on univariable analysis. We will see what all variables out of these 10 variables, how many variables are reaching up till, and what is the cutoff of p-value which we take. So there are various levels. First, we have selected these variables based on the literature search and clinical experience. And then now I will decide statistically. So how I will decide statistically? I will take only those variables, as Dr. Sunil is writing, or Namita, that up till 0.2, up till p-value 0.2, and that I will do as a univariable. So I have a piece of paper and a pen to write. So I'll do one by one. I'll start entering my dependent variable is surgery status. So I put surgery status here. And then again, the interface is same like linear regression. Here you will enter the covariate, which is continuous. So in this box, you will enter the continuous variable which are scale variable. And in this box, you will enter the variable which are the categorical variable. So I'll start with gender because that's the first variable. I'll put gender here in the factor. And for to see the p-value appears here like model coefficient. This is my p-value. This is my p-value. So if you see the p-value of gender, it is significant. So I'm just writing on a piece of paper what all variables are significant. So gender is significant. So I will take gender in my final model. Then next step, I will move this gender back. And then I'll take the other one, age. So age is in the form of a 2 variable. Age is as a continuous variable also, and age is as a categorical variable also. So right now, probably I will take age as a continuous variable. I will enter that as a covariate. And then I'll see the p-value. So if you see the p-value, it is 0.085. So should I take age into my final model or not? Please write yes or no. Yes. Why? Because although p-value is more than 0.05, but still it is less than 0.2. And we have set a cutoff of 0.2. So that's why we will take this also. Again, I will move this back. I'll take BMI. as a covariate. What about BMI? We'll wait for some time. What is the p-value of BMI? As in the model, it is 0.7. So should I take the BMI in my final model? So Dr. Sunil is saying no. So I won't take BMI. Dr. Hilda is also saying no. Okay, but I'm noting down, or you may duplicate because later I need these odds ratio values. So I'll tell you how to do that. So because in the table you will see that we have to report unadjusted odds also and adjusted odds also. So this comes in the model coefficient. If you click that model coefficient, till now this table is not giving us the odds ratio. So you click here, the odds ratio, and then you can see the odds ratio of this particular BMI is 0.99. But we are more more concerned about the p-value. So this is univariable analysis, and the odds ratio, which you can see here, 0.99, this is which type of odds ratio? We have learned two types of odds ratio, unadjusted odds and adjusted odds. So this BMI odds ratio of 0.99, this is an unadjusted odds ratio or an adjusted odds ratio. Please type in the chat box, all of you. Namrata is saying unadjusted. Anybody else? Farzana is saying unadjusted. Okay. So you are right that it is unadjusted odds. Now I will. So should I take BMI? If you see the BMI I won't take. Now coming to the chronic disease. Now all the variables I will move to these factors because all of these are the categorical variable. So I am moving this back to this window. If you see the p-value, for now I am not taking this coefficient because this is unnecessary. I am only concerned with the p-value. So p-value, if you see, there are two. There were three levels, like chronic disease, none. In fact, four levels. So it is comparing the diabetes versus none, hypertension versus none, and both versus none. But the rule here is even if one level is significant, like up till 0.2, you will take. But if you see, none of the variable here is the significant. So we are significant means up till 0.2. So we are not going to take chronic disease in our model. So I have put a cross for chronic disease. This I will not take. Now I'll go to another variable, and this I'm doing the univariable analysis. Admission type. So if you see the admission type, reference is the OPD versus IPD. So will I take this variable into my, should I take this as my final predictor variable? Dr. Hilda is answering yes. So yes, it is, value is, Priyanka is also writing yes. So department, I will take as yes. Then I'll go to anesthesia type. If I move this anesthesia type, then what is the p-value? Again, should I take this p-value? Should I take this variable in my model? Yes. So anesthesia type. Then I'll move this back. Season. There were two seasons, summer and winter. So what is the value? It is 0.9. So I won't take that. So season, I won't take. Now next is the days of week. So days of week. So you see that days are mostly, it is non-significant. There's only one significant. So it is up to you. You can see it, but it is very less chances because it is very high. All these are like 0.6, 0.7, 0.5. Right now, I'm taking a decision not to include it. So I'm not taking days of a week. This is again in the category of not having. So finally, how many? And then surgery type, sorry. So surgery type, if I move the surgery type, planned versus emergency. It is 0.04. So I will take, yes, Dr. Hilda, right? Surgery type I will take. So how many variables finally? Out of total 10 variable, out of total 10, total 9 variable, 5 I included because 5, the p-value of 5 variables were up till 0.2. So I've included them. What are those variables? Gender, age, department, anesthesia type, and the surgery type. Now coming to this was the you can say decision of what all to keep in the final model. Okay. Now I will enter only those variables which are which are up till p-value of 0.2. So I'll move this gender here as a factor, age as a covariate, department as a factor, anesthesia type as factor. So all other and surgery type as a factor. So 1 continuous variable and 4 categorical variable. And then I'll see the other options. So here I'm not using this hierarchical one the way we have seen in the linear regression. If you see the check for the reference level, so surgery is done is my reference because I have to see the surgery cancelled. And then gender, female is my reference. So the odds ratio will be in the male as compared to female. Similarly, the reference here is the ENT. So I'll be telling the odds as reference to ENT. Anesthesia type is general, taking regional, and surgery type is emergency as a reference. So these are the reference level. Again, you can change these reference level. Okay, the way we have seen in the linear regression, you can change these reference level. Now coming to this, I'm not touching the option of this model builder now. This is the reference level, seeing the next value, the assumptions check. So here in the assumption check, there is only one assumption, that is the collinearity statistics. So if you click the collinearity statistics, this is the VIF and the tolerance value. So yes, if you see the individual, you see only one column, and what should be the value of VIF to say that there was no multicollinearity. So it should be less than 10. Here you can say all the variables they have got less than 10. So that's why we can say that yes, there is no multicollinearity. So that assumption is met. Regarding the model fit statistics, if you see there's an overall model test. So you click on there's a overall model test, and this is by default there. So there are basically 4 types of pseudo R-square you see here, but most commonly we report McFadden R-square. There is a Nagalkar R-square, there's a Cox and Snellen R-square, and there's a Jur's R-square. So there are various types of R-square. Most commonly we report the McFadden because this is the most conservative, and if this is significant, if this is like a improvement over null, it is, you can say here, like if the McFadden R square is 12 here. Now, first let me put the command, then I'll show the interpretation. And then here, you have to click on odds ratio and 95% confidence interval. Odds ratio, 95% confidence interval. This is the table. Estimated marginal mean, I will tell you later. First, let me explain this. Prediction, this is regarding this also I will tell you later. Regarding because this is a little bit, ROC concept is there where on the cutoff, because cutoff here it is using that 0.5, which I have discussed, that the probability cutoff it takes as 0.5 and it will show you the accuracy of your model. And then the next is your save option, where you can click on the predicted values and the Cook's distance. Because Cook's distance here also it is important. If the Cook's distance is more than 1, you should not take that particular case in your analysis. Now we will see the interpretation one by one. These are the commands which I have applied. So I'll explain one by one, starting from the. So first is your model fit measure. This is your model fit measure. And this, on the overall model test, this tells you like this p-value tells you like whatever model it is giving, it is significant. Okay. It also gives you the value of deviance and AIC. But for you, it is not important. Why? Because absolute value of AIC and deviance has got no meaning. If you perform the hierarchical, then only if there is a decrease in this AIC and if there is a decrease in this AIC and BIC, then you say that yes, this model is better. So that's why AIC and BIC is not important. For you, you should like put these two values, P value and the R square value, 12%. So why this, how this 12 will be explained? So 12% means there is an improvement from the null model. This model is saying that if you don't keep any variable, then, and if you keep these variables as a prediction, then there is an improvement over null model. What do you mean by null model? Null model means you don't have any predictor variable to predict the surgery. But if you have these predictor variable, it is having a 12% improvement over the null model. That's how we interpret the R square here. It is not in the terms of variance the way we have done the linear regression. And then now understanding these model coefficient. So in this table, it will take a little long and I will explain this table well. So if you see this gender, this is estimate. So this estimate, this table in linear regression, what this estimate used to be, if you can recall the linear regression, this estimate was the beta. Okay. But here, in this case, this estimate is the logit. If you remember the equation, this is the logit. Yes, this is the logit function, logit of B. Okay. So if this is the logit, and if I have to convert that into odds ratio, this is the odds ratio. Okay. So 1.19 is my logit. This is my coefficient. And coefficient is in the form of logit. Remember the equation? I will go to that slide where I have shown you that. Can you recall this? This coefficient, in case of a linear regression, is in the form of logit. Can you recall this? So this is actually logit, which you are seeing in JAMOVI. Now, if I have to convert that back, so this logit, how to convert this logit back into the odds ratio? So if you take the exponent, then that's why you see that in many of the book, it writes like in SPSS also, it writes like EXP and in bracket, it writes the coefficient. That means exponent of that coefficient. So if you calculate the exponent, let me open the calculator. So if this is the natural log calculator. So here, let me calculate the exponent calculator. Exponent calculator. So we will use this calculator, calculator.net. You don't have to use this. I'm just explaining how it converts that logit back to odds ratio. So if you click that exponent calculator, and we have to use E as a base. So I'll click that E as a base. And here what value I'll put? So it was 1.19. Remember, I'm taking this value from that odds ratio of gender. And if I press calculate, what is the value of odds? What is this value? 3.28. And if you go and see this thing, what is the odds ratio here? It is 3.28. Can you see this? These two. So this estimate, what is this estimate? This is the logit of coefficient. And to convert this to odds ratio, you have to no, you don't have to do, software does it. But just to make you understand, it converts that back into the odds ratio by taking an exponent of this and the basically odds ratio. So basically we don't report, or you may report also, it is up to you. But classically you see that in the table, they report up till this point. Odds ratio, ZP, standard error, and 95% confidence interval. And here you will see, now I think we can see with one age, if you see the estimate, it is minus. So what this if the logit is in minus, what we have learned in this session, if the logit function is in minus, the odds ratio will always be less than 1. Now I will calculate this. So this is minus 0.01. Okay, let me calculate the exponent, this thing. So what value I'll put? Here, I have to put minus 0.01. And then I'll have to press calculate. So what is the value? It's 0.99. So if you see that in the JAMOVI, what is the value? 0.99. Similarly, let me show it. So if this regional anesthesia is minus 0.1, 0.85. So if it is minus logit, then what will be the value of odds ratio? It will be less than 1. So again, I will calculate this minus 1.85. Let me write it down, minus 1.85. I'll use this E as a base, minus 1.85. Press calculate. It is 0.157. And if you see the value, minus 1.85, 0.16. No, let me check. Minus 1.85. It is 0.15. And what is the value there? That's okay. It is 0.16 because that is larger than that, like more than 5. It is 0.16. Similarly, if it is 0.64, let's calculate 0.64. So I'll go and I'll calculate 0.64, minus 0.64. 0.64. So it is 0.53. So So you can see it is 0.53. So if logit is in negative, then this is less than 1. If logit is in positive, then this is more than 1. So this estimate is the logit of coefficient. And when you take the exponent, it gives you the value of odds ratio, which the software calculates, but you should know, you should understand how this has come, okay? And the way we have built up our theory, like how we calculate from 0, 1 binary to using maximum likelihood, software calculates probability. Then again, software calculates from probability, it calculates odds, and then it adds a natural log of odds, which is known as the logit. And using that logit function, it gives you the linear equation. And then again, using that exponent, it converts back that to a, because this will be useful in case of those of you who have attended the systematic review and meta-analysis. If you can recall, I think few of you are the part who attended that workshop also. There initially we take the log odds, all the coefficient, generally it converts into the log odds, and then we back calculate the log odds to the odds ratio. So similar to such thing, this is the, like when you take an exponent of log, it gives you back that odds ratio. So that's how. So Farzana is asking logistic we can do for OR, not for RR. If yes, then if my study, can you show me the total chart? Before that, before I take that question, have you understood up till this point, this output? Because there are more output also. Like, can you show me? We can do OR not for RR. No, generally this logistic, it will give you OR, not for RR. It is not yes. It is yes for yes. Your answer to this question is yes. Yes, only for OR. And if your study is cohort and you are planning to report RR, so like regression is not possible. No, if you're like, see, if you're what should I say?
Study design.
No, she's saying study design is if it is like forward, if it is a longitudinal, then also you can calculate OR. It is not always necessary that you will always calculate RR in that. RR tells you, yes, the risk, relative risk or the risk ratio, but this odds ratio, and if you see closely, if the prevalence is less, if it is less than 10%, whatever you are studying, then the value of the numerical value of this RR and OR is same. Okay. So that's why you can, and definitely in all our model prediction, because initially in the beginning, Farzana, you were not there. We have discussed this issue that generally that prediction, it should be, if you are doing the prediction, it should be a forward study, means it should be a cohort study. So if the study is cohort, you should, you can use this OR. There's no issue.
Okay, ma'am, I understood. Just it was my question, whether I should go with RR only or what? And
RR that you can calculate separately, you can calculate RR. Okay,
but
using that 2 by 2. But here, if you are performing a model using a binary logistic, there RR is not the outcome measure. So
okay, ma'am.
you have to report as a OR only.
Okay, ma'am. And is there any options in JAMOVI to calculate unadjusted and adjusted RR both?
RR?
Yes, ma'am.
Yeah, the 2 by 2. Have you attended the basic one? If you
yeah, at that time I have seen for RR, but
okay.
I think it was unadjusted.
Unadjusted, yes. Adjusted RR, no. I don't think, I have not explored and I don't have idea currently.
Okay.
Adjusted RR, no. Unadjusted, that 2 by 2 you can see.
Okay.
Adjusted, I have no idea currently.
Okay. In SPSS also, there is no any options to calculate unadjusted RR, but I have heard, not applied or not tried, but in Strata there is. So just I wanted to explore in JAMOVI.
JAMOVI, I don't have idea. Let me, in JAMOVI, what you can do, I think I have shown this to all of you. Let me show that. you get a very prompt response actually. If you go to this,
कर सकते हैं एस्टिमेटेड मार्जिनल मीन से कर सकते हैं ना आरआर
but that will be,
प्रोबेबिलिटी देता है ना प्रेडिक्टेड प्रोबेबिलिटी देता है आफ्टर एडजस्टमेंट
but can you say that is RR? Like,
नहीं उसका मैनुअल करना पड़ेगा
okay. But what Dr. Shamshad is saying that there is a estimated EMM, it gives you the overall probability actually. Like it doesn't give you in terms of RR. So using that, like he's saying, you can do the back calculation.
बस रेशियो करना होगा दैट इज आरआर
Okay, using the
demonstrate the EMM na estimated marginal mean, that is the predicted probability, and when you divide the predicted probability you will get the RR, and 95% CI also you are getting.
Okay, so maybe towards the end, probably Dr. Shamshad will demonstrate, especially because I am not able to probably comprehend him correctly, but he's suggesting something using estimated marginal mean. You can do that.
Yes,
Okay,
sure,
Farzana.
sure, ma'am. Thank you.
What you can do, what I do. There's a forum in JAMOVI. I think I've said this to you, and they reply very fast. You make your ID, go to this forum, and post your question here. In here, like if I have to post something, you go and post in general. Let's see, you go to this general discussion and you can write your question. Okay, like missing value imputation, panel data, and I can post a new topic. If you click this, and then I have my account, so I will write a subject and I will put that here. You can put a snip also and press that submit. If you press that, their response within, not they, it's actually community. So if someone has done it, they will respond you. Even the Jonathan, who is the who is the person who has started with this JAMOVI and who has made mostly all the coding of JAMOVI, he responds within 24 hours. If
Sure,
he
ma'am.
doesn't respond, then other people respond. How you can do that? So it's
Okay,
very helpful. Even if we are stuck at any level, we always ask the questions from this forum, and they respond. So this is a very useful tool. If you ask from me and maybe Dr. Shamshad, and if we are also not answering, there may be a time then you can post your question here. Somebody will reply.
sure, ma'am. Thank you so much. I'll do that also. And it would be great if at the end of session, if I get some.
Probably, I think Dr. Shamshad is saying something which probably I'm not. Either I will learn from him now, or he will demonstrate.
I will learn from you, man.
No, there are many things. You see, like currently, I'm not able to comprehend. Okay, so I'll go back. And so, are you guys okay up till this point? I don't know. Any yes or no? Farzana is saying yes. What about other people? Okay, Dr. Sunil is writing yes. Dr. Priyanka is writing yes. Okay, Namrata Suresh. Thank you. Now coming to, okay, here also it is not giving you predicted probability because I think there is some issue with that variable. Let me go and change. If you don't put that underscore in the variable, it doesn't, many times it doesn't give you the predicted. Predicted probability. This one, it didn't give the predicted probability. This one. It has given the Cook's distance. That happened, I think, previously also.
Checked hai, unchecked.
No, that's why it is appearing. No, it happened with the previous, in the previous workshop also, I did some change in the variable. Let me go to the data.
Again.
Okay, now it has appeared. So many times it gets stuck. So you can see the difference in predicted probability and the group membership. So if you see here, surgery status is cancelled. This is the actual one. And the predicted is 0.655. So is it the right prediction or the wrong prediction? This one, comment on this. Actual status is cancelled and predicted is 6.655. Wrong. My outcome is surgery cancellation. And if the predicted probability is more than 0.5, then my surgery is cancelled. So then is it right or wrong? My outcome is this surgical cancellation. And surgical cancellation, if that is my outcome, if the probability is 0.5 or more than 0.5, I will say that the surgery is cancelled. Now, is this is right or wrong? So now you got it. It's right. So just see what is your outcome and then comment. Because in the beginning only, I emphasized that my outcome here is the surgery cancellation. So this is my surgery cancellation. Now you see another one. This is cancelled, but the predicted is 0.121. This is a correct or a wrong interpretation. I mean, correct group membership or a wrong group membership? Wrong. Why? Because it should have been more than. Similarly, done and 0.15. What is this? Again, this is a correct one because the group it is less than 0.5. Yeah, you are right. So this is how you can see the predicted probability and the person. In SPSS, they write the group membership also, but here they don't. In the JAMOVI, they don't write. This is the Cook's distance. Again, you can see individually any Cook's distance more than 1. So I think all the values are less than 1. So there's no influential point. It doesn't give you overall Cook's distance. Like in case of linear regression, it gives you the individual Cook's distance. So that you can check. Again, you can go in the descriptive and you can see the minimum and maximum. So I can go to this analysis, exploration, descriptive. I can move this Cook's distance to this variable and I can see minimum and maximum. So maximum is 0.08 if you see these. And minimum is 0.00. So none of the value having more than 1. So there's no influential point or leverage because Cook's distance is less than 1. Now coming to this assumption check, we have already seen this assumption check. Collinearity, model fit we have seen. Odds ratio we have seen. And this we have seen. Now next comes your predictive accuracy. It's the prediction. So if at the cutoff point of 0.5, you see the classification table, your accuracy, specificity, sensitivity, ROC curve, and the area under the curve of your model, which you have predicted using these variable. And wait for some time. Then you can see here, this is predicting the 90, if you see the predicted and observed. So predicted is 408. So it is 99.76 correctly predicting it. And cancelled it is 3.3. So if you see the specificity, if you see the sensitivity, it is very less. But if you see the specificity, it is good. And the area under the curve is 0.74. That means it is acceptable because the minimum level of area under the curve should be 0.4. And the accuracy is 82%. And this is the ROC curve, which is I think you have got a little bit idea about this ROC because we are not going to cover that session. But if you see the basics, this is the ROC. So the more, if the curve is something like that, it should be away from this. Then you say that, yes, the more the curve is like this, then you say that your ability to distinguish between the surgery cancelled and not cancelled is good. It is acceptable. Have you understood up till this point? Then I'll go to the estimated marginal mean. This now, One more thing is left. Ma'am, please explain once more about the specificity, sensitivity, area under the curve. Okay. See, this is if I have clicked that, at 0.5 cutoff level, your percentage accuracy of surgery done is 99.76%. And the percentage accuracy of cancelled, because predicted, if you see this 2x2 table, this is for observed column and this is for the predicted one. So it tells you about the cancelled, it is 3.3%. Okay. Now if you see the accuracy is 82%. The specificity is 1 and the sensitivity is this is being calculated from this only, this 2x2 table. If you can see, this is A, this is B. Okay, this is predicted, na? So this is tested. No, so this is not AB like that, because there the predicted will come here and this thing will go up. So the AB is slight different here, because true positive will be this. This is your true positive, done and done. And cancelled, uncancelled, this is these two. And these are the false positive and false negative. So if you see, it gives you the calculated value. So if you see the specificity is 1. That means it is highly specific, because it is 99%. It is predicting about the surgery. If it is done, the prediction is okay. But for cancellation, it is very less. It is only 3%. But overall, the area under the curve is 0.74. Okay. That how the cutoff level is decided. Remember, Dr. Hilda, we have decided that the software takes a cutoff of 0.5 or 0.5 or more than 0.5 to say that the outcome has happened. It is by default this cutoff. You can increase or decrease this cutoff. If you don't want to keep this cutoff, you can keep this cutoff, let's say at 0.4. If you want to keep this at 0.4, then this will be changed. Everything will change. In that case, you see that your specificity is now 96% and sensitivity is 18. And if you see the R square up, R square is same, because that doesn't change. If you make this as 0.3 cutoff and then see, then your specificity is, because we know that when specificity decreases and sensitivity increases. Now, Pallavi is asking which points we have to report. Generally, we go by default, 0.5. That's the most common one. Because this logistic regression, we take the value at 0.5. So that we should report, that 0.51. So that's why by default, this is the 0.5. And there, this is the sensitivity and this is the specificity. And is this okay, Priyanka? Actually, this is a separate session, ROC specificity and sensitivity. I think we have prior videos, we can share that in the group, because this regression, we are not going to cover specifically the ROC sensitivity and specificity. But if you have got some prior idea, you know that what is sensitivity and specificity. This tells you the specificity, sensitivity, and overall area under the curve of your model, taking the cutoff value of 0.5. So if you have understood up till this point, I think before I explain the estimated marginal mean, I will explain this this table. How do we interpret it? So how do we interpret it? So let's first, now I will tell you the interpretation of this odds ratio, this 3.28. So what does this odds ratio tell me? This tells that odds of surgery cancellation is 3.28 times in male as compared to female. Okay. Similarly, if you see the age is less than this thing. So how I'll say, if in case of odds, there are two ways to express it. either you can express it in the form of like 100 minus odds ratio, or you can express it at its absolute value. So this will gives you the percentage. Like if I have to express that is this value as a percentage, what I will do, 100 minus, if I convert this 0.99 into like whole number, so what I'll do, either 1 minus 0.99 or 100 minus 99. So it is 1%. So I will say that with each 1 year increase in age, the odds of surgery cancellation is reduced by 1%. That I mean, if I want to express it in percentage. If I want to express it in odds ratio, I will say that with each 1 year increase in age, the odds of surgery cancellation is 0.9 times. Decreasing means it is less. So it is odds is decreasing 0.9 times. Coming to any other interpretation, but if you see the p-value, and we will report for especially all the significant variable. So gender and age, they both are significant because p-value is less than 0.05. If you see here also, here only the general surgery and ENT, this is significant. And its odds ratio is 0.03. So if I want to express it in percentage, what I'll do, 100 minus 3, so 97%. So I will say that the odds of surgery, the surgery cancellation, there was 97% odds, decrease odds in general surgery as compared to the ENT. Similarly, if you see this value, regional versus general, this is again significant, and this is also significant. So I will say if odds ratio is 0.16, I might say that there are, if you see the regional anesthesia, the odds of surgery cancellation is 0.16 times in the regional anesthesia as compared to the general anesthesia. Or in percentage, what you do, 100 minus 16, so 84%. So 84% reduce odds in the regional anesthesia as compared to the general anesthesia. Similarly, you will explain this surgery type also, like planned and emergency surgery. So if it is 0.53, what I'll say, there is a 0.53 odds of surgery cancellation is planned as compared to emergency. But 0.53 means it is less than 1. So, or you can say like 47%. So 47% reduced, so 47% reduction or less odds, 47% less odds in of this cancellation of surgery in planned surgery as compared to emergency surgery. So it depends either if you want to say as a percentage or as a odds. So how to report this? So you can see. So this is okay. So this, though, I have told you the adjusted. Now there is unadjusted. In the table, you have to write like adjusted and unadjusted both, because unadjusted you write as a crude odds ratio or unadjusted odds ratio. This, the way you can see here, this is the crude odds ratio. This particular is the crude odds ratio, and this is the adjusted odds ratio. So how to do that? I'll again go to JAMOVI, and here, if in the same table, if you want both adjusted, unadjusted and adjusted, so you can, first what you do, you copy this table, and then here you have to insert one column where you have to write unadjusted. So for unadjusted, what you can do, either you can do like one by one, initially in the beginning, the way we have seen. You can put one variable one by one, keep noting down the p-value and the odds ratio, and then enter it here in the table. Copy paste. How to copy paste? You can just right click this, copy, and you can paste that table in a Microsoft Word document and insert a column and put unadjusted all. Or there is a option in the survival, and this survival is the let me see. What is the death watch? It is not there in there. There's a clinicopath module. I think that is not there. Let me download that. So I'll click on this plus module and I'll click on this JAMOVI library, and then I will select that survival. So there's a this J survival module for this one. This I have installed that, but I think it is writing installed version is incompatible. So I'll again install this, because in this it gives you the odds ratio plot and the odds ratio plot as well as the value also, the adjusted and unadjusted. So it was installed successfully. Now in survival, I can see this clinicopath survival also. So in clinicopath survival, there is an odds ratio table and plot. It is the odds ratio for binary outcome. So I will click this. Here, there's only single window for all the explanatory variable. So I'll put this surgery status here, cancelled, and I'll put all the other variables. So there are only 5 variables which I took. So gender, initially I will put all. Gender, age, because unadjusted I have to report for all. So gender, age, BMI, chronic disease, text this unexpected symbol.
Why unadjusted for all, ma'am?
Because unadjusted you have to report for all. And then you write that in unadjusted the p-value was, we only took those variable where p-value was up till 0.2. And then in adjusted, you put a dash over those p-value which was like more than 0.2. And then you don't take that. That's why. Why this is not taking. BMI, chronic disease. Let me see the variable chronic disease, why it is not taking. Sometimes how you define, means like a chronic disease. Let me put underscore. Chronic disease, it was not taking. Now it is taking. See, that underscore was not there. Many times in JAMOVI, you should have some sign in between. So generally you should put underscore if there are 2 separate words, like chronic and disease. So that's why it was not taking initially. So that's why you will see in every variable we have got this underscore. Admission underscore type, anesthesia underscore type. So this admission type, anesthesia type, department, season, days of the week, surgery type. We took all variable. Okay. So this gives you the, here if you see, it gives you the 2 by 2 table. This is for male and female surgery done and not done. This is cancelled. And this gives you the univariable odds ratio. Okay, and this gives you the multivariable. But multivariable, we don't have to take all the variable. So how I will do? I will duplicate this. So what I'll do? I will go to this click, analysis and duplicate. So I have that table and it gives you like something like forest plot also, this thing, which you see. So this is the odds ratio. This is known as the odds ratio plot. So many times you will see that people show this plot also. And then what I'll do, I will, because if you see here in the univariable, if you see the p-value, I will only take initially the way we have done, like gender, this is significant, Then age was significant. BMI I will not take. This chronic disease I will not take, P.7. Then this is admission type I will take. Department I will take because department it is significant. Anesthesia type I will take. Season I won't take, it is 0.99. The way we have done, remember in the beginning we have put one by one. And then I will only put those variables. So I'll put this BMI out, chronic diseases out, season out, and days of week out. So I have got only 5 variables now. Let me check this. So now you have got a 1, 2, 3, 4 gender, age, department. Admission type was not there. It was, so admission type also I'll move. This was not significant. Again, I will click that so that it will buffer. So this is my final one. So from here, you might, you just copy paste, you select this, you can paste this whole table in the Microsoft Word and make a table in Excel and then paste that. Because from here, you need the odds ratio of only those variables which are like where the p-value was 0.2 or less than that. Have you understood why in the uni variable we have put all the variable but not in the multi? You can do that way also, like putting all the variable one by one and noting down the value. But from this, it gives you the value at one place, and then you can go and make the table like this. Here we have shown with all, I think, but that's not the correct way. That's not the correct way. Here, what should have been done? Like department and all, in the crude it will be there, but in adjusted it will be dash dash. There will not be any value in adjusted. Why? Because I did not take that particular variable in my final. We will correct this table. Dr. Shamshad, this we have to correct, this table. This is not correct, okay? I'll tell you. So this is how we have to report. We will correct that table and then we'll share it again.
Data.
No, in the final table, all the variables are there. So have you understood up till this point?
Lunch के बाद भी break हो.
Can I have any yes or no? Let me check the. Okay. So I think then we can start, we can break for lunch now. And we'll start with the breakout room activity post lunch at 2 o'clock. Is it okay? In the meantime, if you come early, then you can practice. And then again in the breakout room, you can share your screen and show. Is it okay for everyone?
Ma'am, can you just put that admission type back? I saw it was significant. Did I
Okay.
just?
Okay, let me do that. Admission type. It is there above. You can see here. This is admission type. Okay. Yes, it is significant. Sorry. Then it will be also there in the final model. You are right. It is significant.
Yeah, but initially when we checked, it was not significant, ma'am. Initially we tried to put it.
Okay, let me see.
We tried
So
to
what are
check
these?
it out and
Let me see. Let me see.
सबको हटा के सिर्फ admission type रखिए.
If we keep only admission type.
Security purpose. Same आएगा.
It is, I don't know what mistake did I do.
OPD IPD
It is,
नहीं OPD IPD अच्छा ठीक
that is again admission type only. Let me check from, probably, let me check from that, just a sec. I'll go to regression, binomial. Why it got missed? You are right. Let me check once again. So this is my surgery status. And admission type is a categorical. I'll put here. I think I missed it by mistake. Because here also it is coming significant.
highly significant.
I missed it.
Yes. Okay.
So you can include that. When you practice, kindly include that. Okay, I think I could not write probably here. That's why it got missed. I'm sorry.